we'll go on and get started with this here. So we'll skip over the ones that aren't going to show up, but are there questions on 1, 2, or 3 with this here? One of these that y'all want to look at. I can just do number 1 if we want. Cosecant of x is negative 7, 6. With any of these here on 1, 2, and 3, I would just set up my triangle on the coordinate plane. So cosecant is the same as 1 over sine. So whatever sine's values, cosecant's value is going to be have the same sign. So here it's saying cosecant's negative, which means sine is negative. And we also have that tangent is positive. So the coordinate that we need this in is going to be the third. We have our triangle set up, x. So sine of x is going to be 1 over cosecant. So we're really just flipping this here, which gives us negative 6 sevenths. So for our triangle, opposite over hypotenuse. Now at this point here, we can use the Pythagorean theorem to find the other side, which unfortunately is not going to be a nice number, because we're really saying that we have negative 6 squared plus b squared is equal to 7 squared. But really, b is equal to the square root of 7 squared minus negative 6 squared, which is just going to tell us that the value of b is square root of 13. Because it'd be 49 minus 36, which is going to be 13. So our other side over here is the square root of 13, and it will be negative because we're on the negative x-axis. So that's one of the nice things with setting up this triangle. We do have this here. Now you don't have to draw it as big as I did, but we have this here. Now we can find cosine of x next. Well, that's going to be adjacent over hypotenuse, so negative square root of 13 over 7. Tangent of x, opposite over adjacent, so 6 over the square root of 13. Really, both of them would be negative, but the negative and negative would make a positive. And really, at this point, you could have plugged this into the calculator, 6 over the square root of 13, because we know we can't leave the square root of 13 in the bottom of a fraction, which is really just going to simplify to 6 square root of 13 over 13. The next one we can look at is secant of x, which is going to be negative 7 over the square root of 13, which is going to be negative 7 square root of 13 over 13. And again, for secant of x, since we know we have a square at the bottom of a fraction, we can use the 30xs and just plug it in as negative 7 over the square root of 13, hit enter, and it'll simplify it for us. Now we don't have to do cosecant, mainly because it's already given. So we need to do cotangent next, and that's the last one. And cotangent is just opposite or adjacent over the hypotenuse, which ends up being square root of 13 over 6, or we could have flipped tangent and got to this here. Any questions on 1, 2, or 3? Do you feel pretty comfortable with the first 3? Okay. Well, 4 through 7, factoring is not going to be on the test. Simplifying these expressions isn't on the test. 11 through 15, performing these operations isn't there. So you're writing these forms, 18, 19 is not there, 20, 21 is not there. However, we do have some solving. That will be on the test. So, I mean, we can look at 22, or for 22, the first thing we would do is just subtract the square root of 3. Which just tells us that tangent of x is equal to negative square root of 3. And I mean, at this point, we could do tangent inverse of both sides and see what the value is. Or if we look at our unit circle, our little chart that we were given, tangent of x equals the square root of 3 at 60 degrees, or pi over 3. So if I find the corresponding values for it, or essentially when sine is square root 3 over 2 and cosine's 1/2, and the spots where it's negative, those would also give us the angles. So the angles we're looking for this here are 2 pi over 3, and the other one is going to be 5 pi over 3. Or you could have used the reference angle of pi over 3 to find which ones it's negative. It's negative in the second and fourth. So add it, or subtract it from pi, and subtract it from 2 pi to get these here. Does that kind of make sense? Now, I will tell you this, on the test, all of them for solving are going to be between 0 and 2 pi. We're not going to have to try to remember the adding 2 pi, adding pi, the range, all of that there. It will be between 0 and 2 pi. Questions on either one of these here? We ready for the next ones? Any questions on 24 or 25? Questions on these two here? Or either one of these that y'all want to see work? 24. Now 24 is actually kind of nice, and I did give one of these to y'all in Algebra 2. Try to be nice to y'all. But it's a problem set up similar to this here without sine and tangent. That's mostly missed every time. Because if we look at this here, we have two things multiplied together equals 0, so one of them must be 0. We don't have to do anything. We don't have to do any factoring. So we're really saying 2 sine squared of x minus 1 is 0, or that tangent squared of x minus 3 is 0. For this one here, we would add 1 to both sides, telling us sine squared of x is equal to 1. Then we would divide by 2, telling us sine squared of x is equal to 1/2. And to finish it off, we will square root both sides, telling us sine of x is equal to plus or minus square root of 2 over 2. Now, if you want to type those in the calculator, you'll need to type it as the square root of 1 over the square root of 2, or 1 over the square root of 2, to get it to simplify. Now, we can go on and finish this one off here. Now, sine of x equals plus or minus the square root of 2 over 2 is actually kind of nice. Because, again, we can find that on the unit circle. And because it's the positive and negative case, and we're only looking at the values between 0 and 2 pi, well, it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Because we have all the cases where sine is square root 2 over 2. Okay, so we have those answers here. Now for the next one here, we're going to add 3 to both sides, telling us that tangent squared of x is equal to 3. Square root both sides. The tangent of x is equal to plus or minus the square root of 3. For tangent to be the square root of 3, we're looking at just the positive case is pi over 3 is the first place it appears. And kind of a cheat with that one is really the rest of them are going to be with the 3 underneath, because all the 60 degrees or pi over 3 have that. And since it's the positive negative case, we're taking all of them. So 2 pi over 3, 4 pi over 3, and 5 pi over 3. So we actually have 8 answers. For this here. Questions on this here? Any other questions on these two here? Questions on 26 or 27? We good with these two here? Okay. Questions on 28 or 29? Okay. Either one of these, I mean, if any of these that y'all want to see worked or seem challenging, just let me know. We can work it through and go from there. Yeah, which one of these y'all want to look at? 29. CSC of x plus cotangent of x equals 1. Now with any of these here, when sine, either one where we don't have it in terms of all secant or cotangent here, we need to get it to be there. Now, for us, this is a little bit not as nice, because for us to change any of these here, it's nicer if we have it squared. It's our Pythagorean identities. So what we can do here is we can move one of these over to try to make it a little bit better. So I'm going to minus CSC of x from both sides, which will tell us that cotangent of x is equal to 1 minus CSC of x. And it really, honestly, didn't matter. I could have left it alone, because what I'm going to end up doing to both sides is squaring them. Because what we have is that 1 plus cotangent squared of x is equal to CS cosecant squared of x, or cosecant squared of x minus 1. Because we'll end up getting one of these switched out. Now if we square both sides here, over here it's just cotangent squared of x. Over here we're multiplying it by itself, 1 minus cosecant of x, is really what the square is doing. So we'll have 1 times 1, which is 1, minus cosecant of x minus cosecant of x plus cosecant squared of x. So what we end up having is cotangent squared of x is equal to 1 minus 2 cosecant of x plus cosecant squared of x. Now we could replace cosecant with 1 minus, or 1 plus cotangent squared, or we could replace cotangent squared of x with cosecant squared of x minus 1. And interestingly, it's not going to matter either way. Because if I replace the cotangent with cosecant squared of x minus 1 is equal to 1 minus 2 cosecant of x plus cosecant squared of x. Well, that's fine. We need to get everything on the same side of the equation, yes? So I can add 1 to both sides and subtract cosecant squared of x from both sides. Because luckily everything over here is going to become 0. And what's interestingly enough, on the other side, cosecant squared minus cosecant squared is 0 also. So all the squared terms canceled out, and all we're left with is 2 minus 2 CSC of x. Now, since we only have cosecant of x left, we can get it by itself and then try to solve from there. So the first thing we can do is subtract 2. Then divide by negative 2, just telling us that cosecant of x is equal to 1. Now, having cosecant, we don't really have it on the unit circle because we only have it in terms of sine and cosine, yes? But cosecant's the same as 1 over sine. So sine of x, if I flip the value, is going to be 1. Because 1, if I flip it, is still 1. So where cosecant of x is 1, sine of x is actually also 1. So we're trying to find the value where sine of x is 1. So in this case here, sine of x would be pi over 2. Yep. Yep. Questions on this here? Any questions over anything we've done so far? Because cotangents, cosine over sine, 0. So secant, yeah. The answer key has 2 additional answers, 3 pi over 2 and pi, but those don't work. Yeah, I forgot to check those back in. Questions on 30 or 31? 30. So we have 2 sine of x over 2 plus the square root of 3. Well, we can really get this by itself. So we can subtract the square root of 3 from both sides. And then we would divide by 2. Also, we have negative square root of 3 over 2. Now again, because we're keeping this between 0 and 360, or 0 and 2 pi, actually 0, 2 pi, this is kind of nice because again, unit circle. And where sine is negative square root 3 over 2 is going to be at pi over 4 pi over 3 and 5 pi over 3. And we could solve it this way because the only trigonometric function we had was sine of x over 2. So we don't have to use our half angle formula and apply it in here. Now at this point here, we can divide both sides by 2, telling us x is 2 pi over 3. We can do the same thing here, and it'll tell us that x is 5 pi over 6. Because the other one simplified with the numerator, because the other angle, instead of, it would have been 4 pi over 6, but 4 over 6 reduces to 2 over 3. Any questions on this here? Now, ones that you do need to check your solutions on are ones where we square both sides. When we apply a power to 2 both sides, you need to check your answers to make sure that they all work. That's part of the reason that 2 of the answers on 29, the 2 that are faded out, don't work. Questions on this here? We good with 31? Questions on 32 or 33? Yeah. We good with 32 and 33? Questions on 32 or 33? One of these that y'all want to see work. 33. With both of these here, again, we need it in terms of sine or cosine. So we're going back to our trigonometric identity. And for this one here, well, we could say cosine squared of x is equal to 1 minus sine squared of x. So here we have 2 times 1 minus sine squared of x plus 7 sine of x is equal to 5. Now we do need this equal to 0 because most likely we're going to end up factoring. So we will multiply by 2, which will tell us that we have negative 2 sine squared of x plus 2 plus 7 sine of x is equal to 5. Now we can subtract the 5 from both sides, showing us negative 2 sine squared of x plus 7 sine of x minus 3 is equal to 0. Questions on this so far? Now to make this a little bit easier to work in factor, I'm going to multiply, or well, divide the whole thing by negative 1 to get rid of that negative sign. And if we do that, it'll just tell us that we have 2 sine squared of x minus 7 sine of x plus 3 is equal to 0. Since the third term is positive, the signs are the same and they match the sign of the middle term, so we all have negative and negative. Well, I know I'm going to have sine of x in both. And then we'll also need 2 and 1 with sine of x. Now the factors of 3 are going to be 1 and 3. Now I put the 1, the 3, and the 2 away from each other to help get us 7. Because 2 times negative 3 is negative 6. Negative 1 times 1 is negative 1, which will give us the negative 7. And I just didn't include the sine of x. So these are the factors that we want. One of these is a little bit nicer than the other, depending on your definition of nice. Because since we have two things multiplied together to equal 0, one of them must be 0. Now for the one on the right, we would add 3 to both sides, really telling us that sine of x is equal to 3. What is the biggest positive value we can have for sine? 1, yes? So is this even possible? No. That's gone. That's kind of nice. We didn't have to do anything else. On the other side, we can add 1 and divide by 2, telling us sine of x is 1/2, which is actually a nice number because it is on the unit circle. And 1/2 for sine is pi over 6, or 5 pi over 6. And that's it. Questions on this here? We feel pretty comfortable with this here? I will tell you, you could use the quadratic formula for some of these here, but there isn't going to be one that you have to use the quadratic formula. And I will make sure and double check that. And if there are any, I will fix them. Because those are the ones where we get irrational solutions where they don't factor well. So like 35 isn't going to be on the test. One like it where you have to use quadratic formula. Questions on 36 or 37? Plug them in. Just plug them in and solve. And for these here, plug them in and solve. Just make sure that you have the calculator in the correct form. I would use the 30xs for these here so that you do get it in radical form, not as a decimal. I will take it in radical form. I won't take them as a decimal. So use that graph, or the 30xs, get it, plug it in. Make your life a little bit easier. All right. Same with these here and that one. So for 43 through 45, write the expression as sine, cosine, or tangent. So for these here, we're not wanting an actual value. We're wanting a rewritten. Is there one of these in particular that y'all want to look at? And again, for these here, I would be going back to your reference sheet. Because if we look at, say, 43, sine of an angle times cosine of an angle minus cosine of an angle times sine of an angle. And if we look at all of our identities, probably not going to show it to me here. Because this is one of our sum or difference formulas. Because sine of U, cosine of V minus cosine of U. Sine of V is our sine of U minus V formula. And again, that one's just written down on your reference sheet. So for us here, U in our case is 3. V is 1.2. So 3 minus 1.2 is 1.8. That's all it's wanting for these here. In terms of sine and cosine, you're just taking that formula, matching it up, plugging in U and V, simplifying so that we have this here. Questions on this one here? The next one, cosine, would be cosine of 60 minus 15, which is cosine of 45. But again, you don't have to have these formulas memorized. It's more just look at your reference sheet, match it up to the correct setup that it is, and go backwards or forwards. Questions on these four here? We good with these here? Questions on 46 through 50. Now, all of these here there is a setup similar to this on the test, and it's not too bad because the values of U and V are going to be the same for all four. You're not going to have to re-find the triangles with each one that you do. There's the same triangle, same values. So sine of U being 24 over 5, cosine of B being negative 4/5 is going to stay the same. U is going to be between pi over 2 and pi, so over here. V is going to be between pi and 3 pi over 2 down here. So sine 24 over 25, opposite over hypotenuse. As I'm setting this up, cosine of V is adjacent over hypotenuse, which means this other side is negative 3. And this side, I believe, should be negative 7. Because what we're saying is a squared plus 24 squared is equal to 25 squared, or a is equal to the square root of 25 squared minus 24 squared. Second square root 25 squared minus 24 squared is 7, and it's negative. So after I set that up, it might have been nice to have actually drawn that on two separate quadrants because those triangles back up to each other. Does that make sense? I mean, if you can keep straight which one the 7 and 4 is attached to, you can do it this way. If not, that's fine too, separating it as 2. Now for sine of U minus V, this is going to be our sine of U cosine of V minus cosine of U sine of V. And we can just get this straight from the formula sheet. Now sine of U has already been told to us is 24 over 25. Cosine of V, well, they already told us that is negative 4 over 5, minus cosine of U. So if I look at the chart, it's going to be negative 7 over 25. And sine of V is going to be negative 3 over 5. And at this point here, we can plug this onto the calculator. We don't have to do this by hand. We're going to have 125 on bottom. 6, carry the 1, 96, negative. So I believe we should get negative 117 over 125. Yes. As long as the person who made the answer key for the review sheet got it right. I hope they did. Questions on this here? You all want to look at 48, 49, or 50? So tangent. Now, let's see here if they're going to be nice. Okay. That's how they did that. That's if any of y'all have the sheet out, I believe this is the correct setup for this here with our signs. Fortunately, the book did not give me a nice version of it. They decided to use plus or minus on the back, which I don't think is very nice. So minus plus, okay, I did get that right. Now for tangent of V, we can come back to the triangle. So tangent is opposite over adjacent. So this would be 3/4. Tangent of U, opposite over adjacent would be 24 over -7. Send the page. And then we have 1 plus 3/4 times -24 over 7. So again, we're still using those same triangles, just plugging the values in. And again, at this point, either calculator would do this. You can just type it all in exactly as you see it and let it take it from there. And I think it's going to give you -117 over 44. Is that what you got? And that's it for that one there. Questions on this here? Any other questions on these four here? We can look at another one if you want. Tangent of U plus V. Or is it sine or cosine? Cosine of U plus V. Because cosine of U plus V is going to be cosine of V, cosine U minus sine of V, sine of U. And really for this one here, which one you put as V and U doesn't matter because they're next to each other. So cosine of V is -3/5. Cosine of U is -7/25 minus sine of V. No, got ahead of myself. Because that should be a 4. That sine of V should be -3/5, and sine of U should be 24/25. Because sine of or cosine of V is not -3/5, it's -4/5. They told us that from the get-go. Now, after doing the first one, we know that the denominator is going to be 125. -4 times -7 is 28. Minus, well, it's actually going to be plus. 24 times 3, 2, carry the 1, 72. So 100 over 125, which is going to be 4/5. And that's it. So a lot of these four here is, once you get the two triangles set up, it's just looking at the triangles, plugging the values in. Opposite over a hypotenuse, adjacent over hypotenuse, opposite over adjacent, plugging those in and just working it from there. Questions on this here? We'll stop there because we're definitely not going to have enough time to finish all of this here. That's fine. We will finish it tomorrow. We'll finish this up tomorrow. And then your test will be on Monday, unfortunately. But if you do have any other questions on working some of these here,